Okay, it's live now. I'm audible now. Yes. Student's screen is visible to you or not?
Yes, sir.
NVDIU. Okay, cool. So the topic is prism and natural phenomena. Okay. Let us start it now. And I'm launching here poll. So please, okay, so it's audible. Clear? One of the students have texted here, ki, sir, you are not audible. I'm audible. Please text back in the chat box. I'm audible or not? So we can start it soon now because we have already waited for the 9 minutes. Okay. Yes. Shruti says yes. Sakshi says yes. Please admit. Oh, hold. See, don't see. We have two links here. See, if you see this screen, there is Avanti Fellows where my video is there, and my for audio I'm using different mic. It's named as Abhishek Sharma here. Okay. So I have unmuted that mic that is named as Abhishek Sharma. See that tab, and that Avanti Fellows is just for video. So I think it's clear. Jinvi Changlang students, is it clear? If you'll see there, the voice will be coming from that tab, Abhishek Sharma named tab. I hope it's clear to you. That's fine. Yes or no? Okay, let me confirm with the YouTube also. So I'm seeing here on the YouTube. Is it audible there? Okay, it's clear. Yes, sir. Microphone connected. See, it's your problem. See, I mean, Changling students, it's a technical issue from your side, not mine. Because all other students are able to hear this. My voice is clear. If you see, it's available on the YouTube also. Okay, that's fine. No issues, no issues. So I'm closing this video and here we go. So in the previous class, we have seen about the prism. Today, don't worry. We'll be not studying again this prism thing. Okay. So in the previous class, what we did, we studied prism. Ki sir, prism kya hota hai? What is this prism? And how the refraction is occurring through the prism. These all things are completed fully. Okay. In the previous class, if you see the last YouTube lecture, you will be able to see this thing. Okay. So now we'll progress towards the next, but before this, let us go through the revision. So this is now a revision slide in front of you. Revision. Okay. So what is happening here? If you see, this is a white light, and we know white light is what? So white light is the combination of 7 colors. Okay. So this white light is coming on one side. It's falling on one side of this prism. Prism is triangular kind of structure here, glassy structure. You can say that this prism is made up of a material, maybe glass or whatever, but this is made up of material glass. And for glass, the refractive index is defined as 1 point, how much? It's 1.33. Okay. So when the white light is entering in this, on the one surface of this prism, so what is happening? It is getting refracted like this. And on the other side, we get 7 colors. Okay. So see, refraction is happening, but with the refraction, what's the next thing which is happening? It is dispersion. With the refraction, one more thing which you are able to observe here is dispersion of light. And especially which kind of light? Dispersion of white light. And why we have used this white light here? Because from this, it gives us an output as a result as 7 colors. Okay. So we can say white light is made up of 7 colors. Okay. Is it clear? Yes or no? Okay, let us move toward the next now. So while studying the refraction through the prisms, we came to know this thing. Hold on. Okay, this is what angle of prism. This is what angle of prism. Angle of prism. Angle of prism. See, if you focus here, this angle of prism maybe can how many values it can take? Angle of prism, how many values it can take? It can take 60 degree or it, yes. It can take 60 degree or it can take other values which are very small here. Okay. Like maybe 4 degree, maybe 6 degree, maybe 9 degree, maybe 10 degree. Okay. But we'll take this value as 60 degree for now to understand the concept. See, Changling students. Okay, let me confirm you this thing. See, JNV DIU students, please text me in the chat box. Am I audible you clearly? Am I audible to all of you clearly? First of all, JNV DI students. Sakshi, text me here. Am I audible to you clearly? Let me confirm Changling students. Okay. So, Shruti, please text me here. Am I audible to you clearly? Okay, Shruti says yes. JNV DIU students says yes. Okay. So, is any other like here in the chat box? Sakshi says you're audible. That's fine. How many students are there in the participants list? Jinvi Aravali. So Jinvi Gondia and Jinvi Aravali students. Please, you people also text me. Jinvi Ratnagiri also. Am I audible to you or not? So we can let us confirm ki where is the technical issue. If I am wrong, I'll do something. Audibility must be clear. It's not about that mic. Okay, mic can be different. I'm using different app. Okay, you people have texted me. Yes. So see, it's confirmed. Yeah, I know D. I know DIU is a place, but I'm asking you. Am I audible to you? DIU. It's Dew. I think it's Dew, you know. You please can you put a text in the chat box? I'm audible or not? DIU students? Yes, sir. Okay, Changling students, so it's cleared. All of these GNV students plus the people like students who are attending individually, they have texted ki sir, you are audible. Okay, so I hope it's clear. So let us approach back towards the slide. If you see here, see this ray is which kind of ray it is? Incident. This incident ray is entering on this side. Okay, so when it touches the surface of this prism, it gets refracted. You can see, and this angle here, if you'll see, is nothing but the angle of refraction. This angle is the angle of refraction. This is angle of incidence. And when this ray, which is inside it, when it reaches on the other side, slant surface, it will again get refracted like this. Now this angle is known as E. Why it is given by E symbol? Because it is emergent angle. And this ray here is known as emergent ray. Okay. See, the things which are important here, if you see, this is angle of, I have told this in the previous lecture. Is the voice clear now? Okay, I'm unmuted. I think now there will be dual problems there. So write this angle of prism to be R1, R2. See, this was one thing which we have studied. Let me highlight this point. No need to write it here. See, what is the important point on this screen? I'm highlighting there. Okay, no need to consider the full definition. It's not required. It will take a lot of time now. Remember this. This angle of prism equals to R1 plus R2 is the important point here. This angle of prism R1 plus R2 is important point here. Okay. equals to 1 plus I minus R1 upon minus R1 plus R2. This is known as angle of deviation. Okay. So I have highlighted both the formulas in front of you. This is the number one formula. This is the number two formula. Remember both of these formulas. You have to remember it. Okay. Where this is angle of incidence, angle of emergence. This is the angle of prism. This is refraction angle at one side of the one slope of the prism. This is refraction angle at the other side of the prism. Now just focus on this graph if you see properly. See this. So it's a graph we have seen in the previous class also, in which what was happening, that for a same angle of, see, this is the angle of, here if you see on the x-axis, this is angle of incidence, somewhat some angle between 40 and 60 degrees. So corresponding to it, angle on the y-axis is this, which is angle of deviation. Okay. So we say there will be one angle fixed for I equals to E. Okay. This is angle you can see here. What is happening? This is for I equals to its one angle. Okay. But if you see, if you mark the other points on this graph, you can see here properly. This point is here. This is the angle of incidence here. Okay. So for this angle of incidence, there are how many angle of deviations? One. Fine. But for this same angle of deviation, there will be two angle of incidence. Remember this thing as per the graph. Okay. So basically conclusion is this, that you will find here the ranges you will find here in the from this graph, ranges of angle of deviation. You'll find here on this graph ranges of angles of deviation for which angle of incidence will be same. You'll find the ranges of the angle of deviations. Sorry, I have to change some word here. Ranges of angles of incidence. Ranges of angles of incidence for which angle of deviation will be seen. So you will find mainly two different angle of incidence for which you can see here, for which angle of deviation is common between 40 to 50 here as per the graph. Okay, this is the point to be concluded from this slide. Next is what is minimum angle of deviation? Remember it, this is given by the formula which is in front of you on the screen, no need of the derivation. So ultimately we'll get this thing, that is minimum angle of deviation is given by this formula. I'm putting this formula in a box. These are all theoretical aspects. Okay, we have already seen in the previous class. Minimum angle of deviation is given by this thing, that is n21 minus 1. What does it mean? It means refractive index of the inside medium with respect to the air. Okay. See, what was our formula? Our formula was this, mu minus 1 upon mu minus 1 into A. That is angle of prism as per the previous slides. Okay. Okay, students, this mu is what? Refractive index. Okay. Now this was a question. Can anybody solve? Just apply the formula. Minimum angle of deviation is given by refractive index of the medium minus 1. Which medium? Prism medium. Refractive index of the prism medium minus 1 into Angle of prism. Just Changlang students have raised the hand. What happened? Changlang students. What is happening to you? An issue? We can text here. Yes, Changlang students, what happened? Okay. Please solve this question, students, and find the answer. It's very simple. You have to just put the values here. Put the refractive index of the prism. Put the refractive index of the prism. Put the angle of the prism. From this, you'll get the angle of deviation. Solve this fast. Put angle of prism. Okay, so one of the students have solved it. GNV DIU students, 2 answers. Excellent, very good. DU students, excellent. Okay, great. So let me show you here how to solve it. Very simple. So minimum angle of deviation, mu is equals to 3/2. Okay, minus 1. Angle of prism is 4 degree. So when you will solve this thing, you will get 3/2 minus 1 is how much, students? 3/2 minus 1 gives you what value? It will give you the value of half into 4 degree. So this gives you angle of deviation. Angle of deviation equals to 2 degree, which is the right answer. I hope other students also got the same answer, isn't it? I hope other students also got the same answer. Clear? So this is 2 degree answer. So if I show you the main solution, it is the same 2 degree. Okay, now let us move towards the next thing. So there is one more numerical, but we are not going to solve this. You will find, you may find this on slide. Let us see somewhat about the dispersion of light now, because we also have to complete this chapter today. Today I'll complete optical instruments fast. Okay. Dispersion of light. What is it, students? So be quick. Be very much alert in the class. Dispersion of light. I told you already. When a white light is basically what? It consists of 7 colors. 7 colors means what, students? 7 colors means Vibgyor. Violet, indigo, blue, yellow, orange, red. We all know these things. Yes, splitting of light. Okay. See, this is a kind of part of the electromagnetic spectra. We know electromagnetic spectra, it consists from the radio waves to the gamma X-rays. Okay. So in between, there is some range of that electromagnetic spectra, which is given by the name visible range. Visible range. Okay, and it is in the range of 400 nanometers to 700 nanometers. Okay, this is in the range of 400 nanometers to 700 nanometers. Okay, if you see here, this is which color? Violet color. Violet, indigo, blue, orange, red. Okay, and this last will be red there. So this will give you complete definition like Vib Your. Okay, this is green is here. Got it? So you will see here that if white light is coming like this, white light. So after passing through prism, it will disperse. It will show 7 colors, which are in the band as shown you on the screen. Okay, so let us see. So this is something source of light. Let us take a prism. Okay, let us take this, set it as like lambda equals to 400 nanometer. We know this lambda equals to 400 nanometer is for what? Okay, let me on the video. So there's an animation for you people. See this. As I'm increasing the lambda, you can see how the emergent rays or emergent angle is what? It's changing. Okay. So this is the white light. Okay. Now white light you can see as it is passing from one side, incident ray, and emerging outside, it shows 7 different rays of different color in a continuous pattern, in a continuous band. This is known as dispersion of light. Remember, this is known as what? Dispersion of light. Let us see again. So this was just a simple light. If I increase this lambda from violet to the red, you can see how the emergent angle is what? it's decreasing. Okay, emergent angle is decreasing here. Got it? And if I show this with white light, you can see here. So that angle of the red, you can see it's less as compared to the indigo violet angle, violet light angle. Okay, got it? So this is nothing but the dispersion of the light by prism. Remember always that refractive index in this case, okay, is always of the medium. Okay, you will listen here, you will see here, that is n value is inversely proportional to lambda square, and we know lambda for red is greater than the violet. So we'll see here that n will be greater than the red's value. So minimum angle of deviation for violet will be greater than red. Okay, let me show you this thing again. See, it says like this: refractive index is inversely proportional to lambda square. Fine. We know this red is having the longest wavelength magnitude, also as per the band also. Its wavelength is so much. Okay, if wavelength is so much, with if we see this relation, n will be proportional. Okay, sorry, it's inversely proportional. So lambda increases double, refractive index decreases. So that's why we are saying if this is a relation, this will be now greater than the red value. So through this we'll get angle of deviation like this, which is having this value. This is the angle of deviation value. So from this we get this thing. If you are using in a prism which is made up of whatever refractive index, we'll say for violet light, angle of deviation will be greater than the red light. Conclusion is this, remember always. We'll say like this, that for violet light, angle of deviation or minimum angle of deviation will be greater than 4 as compared to red light. Okay, remember it always. So now suppose it shows here it's how the lambda is increasing. So with increase in lambda from blue to red, violet to red, you can see how the emergent ray is moving its with its direction. Okay, if we use the white light now, it's dispersion. Fine, clear. Now let us see the natural phenomenon in this optics chapter. Natural phenomenon due to sunlight. See, sun is having the watch. It's a natural source of light. So as the sunlight is coming to us, you know how it shows different patterns, the rainbows and all these things. So that we'll see now. Okay, so watch here on the slide. See, you have seen this thing. See, sun is moving like this. So what is happening? Rainbow. Let us see the slide again. So you will see rainbow is in front of you while your back is to the sun. Why it happens? When there is rainy season, or when the rain has just, the rain came and it went just. Okay, there is no rain now, but it just was recently. Okay, it passed now. So if you keep your back against the sun, your eyes, or you'll be able to perceive, you'll be able to see the rainbows like at different random places. Okay, so why it happens? See this again. So as the sun is back, actually we are the animation is made like this, that the sun, our back is to the sun. Okay, so what is happening is this: water droplets are behaving like a triangular prism, and when the white light or source, because the sun is a source of light, and that white entering light when enters in this water droplet, which is behaving like a prism, it shows the dispersion phenomenon, and that's why we're able to see the rainbow colored kind of things, which we call it as a rainbow. Okay, so see here now. So what is happening? As our back is to the sun, we are able to see the rainbow. Why we are able to see? Because rainbows are nothing but water droplets in the atmosphere are behaving like a triangular prism. And when the light from the sun is coming and touching these water droplets, it gets dispersed. Dispersion is shown by, because see, many water droplets will be there in the air. Due to what? Due to as the rainy season was there, so humidity was there. Water droplets you will be able to feel also in the room. So when these water droplets are hit by this kind of sources of light, I mean sun rays. Okay, so these water droplets which are acting like a triangular prism, they will disperse this white light into 7 colors. Okay, is it fine? So now let us see the scattering of light. We have seen the dispersion phenomenon shown by sunlight when it touches the water droplets, and we know that 7 colors are coming out. The 7 colors are coming out. Okay. Now let us see this scattering of light. What is the scattering of light? If you focus here on the scattering, see incident light. See when the light passes through an imperfect medium. Imperfect means which is having the variations in refractive indexes. Remember it always. Which is having variation in refractive indices. Such a medium which is having variations in refractive indices is known as imperfect medium. Okay. So it says when a light wave passes through an imperfect medium, then it gets deflected off its straight path and scatters in many directions. So this is a light, incident light, and you can see after scattering, it shows that its path gets break into different directions. Okay. So you can see this phenomena. See this carefully. It is due to the scattering of light only that you're able to see the sun. I mean, see that water you're seeing it's blue. Okay, so sky also you're able to see blue. Why? What's the reason that the water? See, water is having no color. It's transparent kind of. Okay, I'm repeating it again. See, let me explain you this thing. See, if you see the atmosphere on the top, atmosphere outside, the sky. Okay, if I call up, if especially if I call for the sky. Okay, if I say that watch the sky, see the sky there. Okay, so what is happening there? The light which is coming from the sun, it is entering the sky, and I tell you, the sky is not having a perfect layers of refractive indices, or I will say atmosphere outside is not perfect. It is having the layers of refractive indices. I mean, it's an imperfect medium, the sky, atmosphere outside. So when the light is entering like this in this medium, okay, or suppose okay, yeah, light enters from this into this medium, and it is up to the ground, okay, say up to some water, like say pond or ocean. Why we're able to see that blue color? See, water is not having any color. Water का तो कोई color नहीं होता. So why it happens that we are able to see somewhere the water color is green, somewhere blue? Why is happening? This is due to the light incident. Okay, when this incident light passes through this sky, which is an imperfect medium, imperfect. I'm saying imperfect. IMP perfect. This imperfect medium. Okay, imperfect means variation in refractive indices. So it will show different refractions, angles, and ultimately it will give you what when it enters. It appears to our eyes. So after touching this water, when it gets reflected and enters into the eyes, we're able to see the blue color. It is due to not due to this water actually, but it is due to the process of multiple refractions. And basically, this multiple reflection is not the initial process, the starting source. Starting source is scattering. Light gets deviated into different colors, and after multiple refractions from the layers of the sky, it is entering into our eyes. Okay, is it clear? Yes. So this is a reason why you're able to see this blue color. See, sky ka water, see, sky's color you'll be able to see blue. That's fine. Water color is blue. Why is it? So that's the reason you can say for scattering here. Okay, clear? Why? I hope it's clear to you. If you're having any doubt, you can text in the chat box. If you're having any doubt, you can text in the chat box, students. Is there any doubt for scattering? I'm waiting. Text in the chat box. Okay, let us start now scattering. We have completed scattering now. Do you want any more examples? Do you want more examples? Okay. So listen, I'm giving you one more example. See here first. Have you seen this Rayleigh scattering? Okay, remember always Rayleigh scattering is inversely proportional to lambda 4. Okay. More scattering का मतलब क्या? Okay, let me tell you this thing. Okay, I'm giving more examples. See, you have seen the red effect due to sunrise, and first of all, text me. Have you seen the sunset and sunrise near the oceans or nearby your some open areas? Have you seen the sunrise and the sunset? Yes or no? And if you've seen the sunrise and sunset, you might have also seen the red color atmosphere with that. Yeah, Changlang student says yes. Excellent, Changlang students. If you have seen sunrise and sunset, you probably have also seen the red color atmosphere with that. Okay, so that is due to the process of scattering of light. So as this light which is entering, okay, when it gets struck by some dust particles in the atmosphere, it gets scattered into different directions. Okay, so after getting scattering matlab getting deviated. Write this definition. Scattering matlab deviation of light. I'm going very basic now for this. Deviation of light when it passes or gets struck or meets some dust particles in the atmosphere or some particles like this, water droplets, anything. So their paths, see, water droplets, if you'll meet, that water droplets will act as prism. So for dispersion will be shown, okay. But if it's meeting some particles, dust particles, because see, in the atmosphere is full of what? Atmosphere is full of gases and many other things, okay. So dust particles will also be there. So when the light touches this dust particles, okay, what happens? It gets deviated like this. And until, before entering into our eyes, as it enters, okay, it shows us something different. The picture is something different. Okay. So see, when you have seen the red atmosphere during sunset or somewhat yellowish during sunrise, it is also due to this scattering only. Remember all this. It is due to what? It is due to scattering only. Okay. Okay. Have you heard about Tyndall effect? Students, have you heard about a Tyndall effect? Anyone? I'm asking, have you heard the Tyndall effect? Okay, see. Okay, cool. So always remember this. What is scattering? Matlab kya hai? I'm giving you one more very simple definition. So if the light strikes some dust particle, okay. So if the dust particle, what it does? See, this particle will absorb some will absorb some of the portion of the light. This dust particle, see this on your screen. This dust particle will absorb some of the portion of this light and it will scatter other portion. Okay. And it will scatter other portion. So scatter means it will deviate the rest of the light in different directions. Okay, this is known as scattering. And this violet color light scatters most. It means it will show more deviation as compared to this red light. More scattering means what? See, lambda decreases, scattering increases. Lambda increases, scattering decreases. So you can see here, it will scatter the least. Red light scatters the least and violet light scatters the most. Okay, that's why when the sun is going like, we see in the ocean red during sunset, red color. Why? The reason is due to scattering. Fine. See this. You are able to see this orangey kind of reddish color during sunrise or maybe nearby sunset. The reason is what? Reason is scattering only. Okay, let me explain you this thing. Now, please be focused. You want the complete explanation? No, I'm giving again. See this. This is red color or orangish color. Okay. If we see the spectra, orange color falls where? It's somewhat here. We can say somewhat like 600 to 700 nanometer in between. So how it is happening? Let us observe. See, we are an observer standing here. We are an observer standing here, okay? And sun is nearly overhead to us. This is sun. It is, yeah, I'm explaining scattering example for you. You only told me, no. Sun is nearly overhead to us. And we are standing here. This is we as observer dancing here. Okay. Sun is overhead to us. That's fine. So we are able to see this picture now. But what happens when this is our distance from the sun, okay, whatever, it's overhead. So distance, see, this is the earth planet, mother earth. This is, we are standing on this. And the remaining gap is the gap between what? Atmosphere, okay. So distance of the atmosphere through which the sunlight travels in atmosphere. So this is our atmosphere. We know atmosphere is made up of what? Different layers, stratosphere, troposphere, ozone layer is also there in particular kind of sphere here, okay. So these are the layers of atmosphere. Are you able to see this? See, I'm drawing it here. See, Earth planet is up to here only. Remember always, Earth planet's periphery is this much only. Remaining this blank portion is the atmosphere. It consists of layers of different refractive indices, say N1, N2, N3, say N4 up to Nn. Is it clear? First of all, text me here. Up to this, is it clear what I'm saying? The sun is overhead, observer is on. Now I'll shift something here. I'll show you animation. Then you will be able to understand how that color is coming into our eyes. Water's blue color or sunset or sunrise red color. Okay? Please participate here. Yes. यहाँ तक समझ में आया? Is it clear? Yes or no? I want the complete Changlang students. I hope it's clear to you. Fine. Okay. So see, now let us see the next. Scattering कैसे होगा इसमें? How the scattering will happen? Okay, DIU students, good. So next, see, when the sun is, see, this is overhead. This is the origin position. Origin means horizontal. This is a horizon position. Horizon. When sun is near the horizon. So now what will happen? The rays, see, when it is overhead, it will show this kind of color. When it is near the origin, okay, it will show you this. Why it's shown by red? Because this is a sunset condition. You can say sunset condition. So when the sunlight, which is basically like a white light, okay, when it enters into the atmosphere, which is basically made up of different layers of refractive indices. So it shows, you know, in the atmosphere consists of what? Atmosphere consists of droplets of particles, water particles, humidity. See, when we see the atmospheric news, when we see the weather news, I hope you see the television, okay. So whenever you see the news, if you just switch to the weather news, when that weather telecast is there, so it gives you the humidity range also, no, the temperature, humidity, and all these things. Humidity means what? Basically, you know, something which is connected with the water, okay. So there will be water droplets which will be acting as a prism. There will be dust particles which will be showing the scattering, that is deviation of the rays. This will be showing the dispersion above, that is water droplets acting as a prism. So when this light which passes through this atmosphere, which consists of the water droplets, dust particles, and the layers of different refractive indices, it will show after going through the three processes, namely refraction through the layers of different refractive indices, dispersion, that is 7 colors, and what's the next is refraction, dispersion, and what's the next is, students? Scattering. Mainly scattering will dominate here, because it is due to scattering only that we are able to see the deviations of the rays in many randomly in the atmosphere. After that, it comes into our eyes, okay. So after going through these processes, light enters into our eyes, okay, and then we are able to see that red color of the light or orangish color of the light when the sunset is there, okay. So let me show you this thing. See, angle of deviation shown by the prism is this, okay. Angle of minimum deviation is shown this by the prism. So minimum deviation means what? Let us take that water droplets. These are the water droplets. Let us take this water droplets as like simple triangular prisms having very small angle of prism. So when there is a small angle of prism, I will say I'll use this formula for minimum deviation angle of prism, okay. So deviation shown here, if you put the formula, we know refractive index was inversely proportional to lambda square. Okay, and we know that lambda of the red is greater than the lambda of the violet. So if lambda is greater, refractive index will be less. Okay, violet ka lambda is less, it means refractive index will be more. So we'll conclude here. I've already shown this thing that if refractive index of the violet is more than the refractive index of the red here. So when you will put this value, you will get deviation angle like this, that deviation angle of the violet is greater than the deviation angle of the red here. I repeat it, deviation angle of the violet is greater than the deviation angle of the red here. Okay, that's why the violet light deviates more than the red light. Okay, and if you see here at the end, when the sun is near the origin, deviation shown is less by the red light. Okay, so we are able to see the light which is near to us as red, and we see the atmosphere like this after the complete scattering. But when sun is on the overhead, you don't see like this. You see somewhat like, violet, like sky is something bluish kind of. Why? Because it is overhead. So when light passes through the layers like this in front, okay, it doesn't show. See, if you consider the normal rays, it will not show any refraction. Okay, dispersion somewhat. So scattering shown by the violet is what? It's more here. Okay, so the light which is entering is violet somehow into our eyes, and we see bluish color there. Got it? I hope now it's clear. You can even match the mathematical equations here. These are very easy things. That violet shows, because it is having the less wavelength, it will show maximum scattering, and red is having the maximum wavelength, it will show least scattering or deviation of the rays after it strikes the dust particles. I hope it's clear now. Okay, so little bit of the optical instruments we'll see fast now, and then the next class tomorrow, or maybe after 20 minutes after tomorrow, we'll see wave optics. Is it clear? Students, did you understood all the things today? That we started with the natural phenomenon also, rainbows, scattering. Is it clear? Please text in the chat box so I can give you a little bit more information about this optical instruments. Tomorrow we'll, for 25 minutes, we'll study optical instruments. Then we'll start a new chapter, that is wave optics. Please don't miss the wave optics chapter. That's very important. I mean, it's easy also as compared to ray optics, and also very interesting. You will see many beautiful animations there. Okay, a very good PPT is designed for you for the wave optics. Is it clear? A very good PPT is designed for all of you for the wave optics. Is it clear, students? So please come tomorrow. We'll be happy. We'll study. We'll enjoy the subject. Just 25 minutes of the topic of this ray optics. That is the last. Optical instruments is remaining. Okay, Pooja, I've also joined Aravali, and yeah, you always come in the class. Good. Finish. Okay, JNV Changling students. Fine. See, optical instruments tomorrow will, this is for tomorrow, not now. Okay, 25 minutes will take for, I'll take for a few people for tomorrow, and then I'll start wave optics. Okay, so these are the contents of tomorrow's class. Tomorrow we'll study different optical instruments, and among different optical instruments, basically we'll study the microscope also. Microscope. Okay, what is this microscope? We'll not go into the depths of the microscope, but we'll study somewhat key how the image is formed by microscope, not from outside, but from inside. Which kind of lens is used? Is it diverging lens or it is converging lens? We have to see there. So we'll see image formation by microscope. We'll see magnification by microscope. We know microscope is what? And if we want to see some bacteria or some kind of these things which are microscopic, microorganisms in the bio experiments we have seen, we can see those things with microscope. So we'll see image formation kaise hota hai by microscope. We'll see magnification. So as you take a microscope, you see like this, no? So how that magnification is happening, we'll see that. We'll see telescope also. So there is difference. A microscope is for seeing the microorganisms, small things, micro level. Telescope is for macro things, I mean, which are far away. Micro, which is very near, very small. Macro, which is far, heavenly bodies. Okay, so we'll see for them. Telescope, how it forms the images. We'll see that also. And then magnification by telescope. So this all comes under the category of optical instruments. This is the contents for tomorrow's slides. Okay, so First, we'll start with a simple microscope. I'll show you that microscope are two types of simple microscope and compound microscope. Through the picture only, it is already completed. I mean, you can imagine. You cannot imagine. You can just see and you get it. Simple. Simple matlab simple. Which I was having in my geometry box. In these lower classes, we would have geometry box big, and that small lens used to come. If I keep this lens in front of sunlight, and below this lens, if I'm keeping some paper dry or dry leaf kind of, okay, so it may catch fire or the smoke will start appearing from it if I keep that lens in a static condition. Is it clear? Okay, that converging lens. Okay, so it's basically a microscope, but through this microscope also it happens. This is a simple microscope. We have seen detectives animations. Have you seen the animations? Cartoon series. In that, the detective always is having in his hand this kind of structure. It's a simple microscope to zoom the things. Got it? This is a laboratory microscope. You have seen the labs whenever you go in the labs. And the bio lab, of course, sure it will be there. Okay. We'll study about the simple microscope, that what is the mechanism inside going on. I mean, which kind of lens we are using. We'll get to know that we are using in a simple microscope converging lens. Okay. And then how the things are, how the image is formed. You will see all these things. Okay. We'll study about the nearest point, defects of the eyes also we'll see. Nearest point is what in the eye. Okay. And then what is the far point, that also we'll see. We'll see the angular magnification by microscope. We'll derive a formula tomorrow that is given by this very simple formula. This is a very simple formula of magnification shown by a microscope, angular magnification. Then we'll see tomorrow that different cases when the image is at infinite. So what the result which is shown by microscope, magnification shown by the microscope. So we'll see this when the image is at infinite. And when the image is at near point, so you'll see magnification shown is something different. Where d is the distance. Don't take it as deviation angle minimum. No, it's a distance. Okay. After this, we'll talk about the simple microscope, that magnification due to simple microscope is inversely proportional to focus. Then we'll talk about compound microscope. Simple may only one lens converging is used. In compound, you'll find two kind of converging lenses. Okay. In compound, you will find two kind of converging lenses there. Objective lens, eyepiece. So all these things we'll study in tomorrow's class. Now, students, the time is up. Okay. Also, tomorrow we'll see somewhat about the eye also, the structure of eye. I'll put here on the slide. Okay. So after 25 to 30 minutes tomorrow, we'll start the wave optics. That is a fresh new chapter. Okay. Okay, I'll give you the questions tomorrow, somewhat to solve as a homework. Not now. Now it's time to end the class. Okay, students. Got it? So thank you for the class attendance. Now it's time to leave here. Okay. Hold on, students, 1 second. Okay, students, so that was all about today's class. We'll meet in the next class. Okay. Till then, bye-bye. Thank you, all of you. Okay, JNV DIU students, bye. Pooja, bye. JNV Aravali students, bye. JNV Changlang students, bye, everyone. A wrong slide appeared here. Just hold on. So bye-bye, everyone. Best of luck. Study well. Be happy. Okay. Bye-bye, everyone. Study well. Tomorrow, just I'll take you 25 minutes to complete optical instruments, and this ray optics chapter is checked. It's checked out. Okay, it's completed now. Okay, then we'll start with wave optics. That is your second chapter, and a very animative chapter. We have a lot of animations available for wave optics. So complete lecture will be like you're seeing a movie, cartoon movie. Okay. Okay. Bye everyone. Bye students. Okay. So I'm going to end it now. Okay. So we're having 2 more minutes. After this, I will end. Okay, now you can leave. Okay.